Hi guys, welcome back to another Scientific Weekly. Today's article is going to be either fantastic in the future or it's going to be absolute bullcrap. So the source of today is nature.com and we are going to talk about a new type of filter that allows you to filter water efficiently and quickly. Up to 99.4% of contamination of heavy metals gets removed with this filter. That's a huge amount. And the claims they make are incredible. But because they are incredible, it is also unbelievable. So it is peer reviewed, so it's completely possible that it's true and that I'm just missing on some information. So let's go down to it. So the main material for this product is quartz wool, which is not rare because quartz is made of silicon and oxygen, one silicon atom, two oxygen atoms. That creates the mineral of quartz. So it's far from rare, which allows it to be cheap, but there are also some huge ass problems in it. Alright, let's start with the first factor. So it's quartz wool, and on the quartz wool they placed in a solution that allows it to grow carbon nanotubes on it in certain solutions. The chemicals for it are partly, well, this growth chemical is easy to get, but there's also a chemical that's needed as catalyzer to speed it up, and that's not a really cheap chemical. Another problem is that according to the article, the CNTs, carbon nanotubes, were grown at a temperature of 900 degrees Celsius, which is 9 times the temperature at which water boils. Now, I asked you, do you have an oven in your personal possession which allows you to reach that? Probably not, unless you have your own chemistry kit in-house with specialized gear. But that makes the claim of it being 25 cents a gram for this filter makes it really unbelievable, because the temperature is not easy to reach, and on top of that comes the substrate using toluene for the carbon source and ferrocene as the catalyst to speed up the process and grow the tubes. That is basically just the beginning of the problems. Something else is that 1 gram of this sand filter allows you to have a potential of 83,000 liters of water. Nearly 100,000, well, nearly, it's close to 100,000 liters of water content that gets filtered through the single 1 gram filter, which should be sufficient for 11,000 people. So if we run some numbers on it, let's say it's about in 10,000, so we're gonna divide 83 by 11, then we get 7.5 liters of water for each person. But in what rate? An hour, a week, a day, a year, a month, every 12 hours? Are some details that are actually very useful in this stuff, but it's just missing. We are incapable of adding a real number to it with real means. 7.5 liters, that's probably the usage of people in the Netherlands here every day, so that seems viable. And then it comes 7.5 liters means washing clothes, washing dishes, showering, toilet, and drinking. 7.5 liters per day. But that's not mentioned here, so it's here quite a big gap in information. Maybe they are calculating it a week and then 7.5 is very little. Maybe they calculate for a different area, but of course it's the abstract, it's kept short, but it's not information I could find back in the article. Oh, by the way, the article is fully public and open to read, so the link will be down below in the description as always, and you can read it yourself, break it down. I will also place the Reddit link to the topic that discuss this because there are some really major points in it, and they basically get to the same. The numbers don't make much sense. The numbers are like, look, we discovered this, these are the numbers, figure out yourself what it means. That's not really helpful. So I don't know what to think of it. The whole article is not too lengthy if you ask me, and it's reasonably easy to read if you ask me. Also, lots of references and stuff. But yes, it's not rare. It filters on heavy metals only, so you need to work with recently, well, actually pretty clean water already. Microbiological contamination does go through this filter, so that's a downside. It's supposed to be cheap, but 900 degrees Celsius and the required chemicals make it less cheap and less viable in some countries where they have not so much access to those substances and devices to reach the temperature. Carbon nanotubes, so if they always behave the same, it's good, but there might be a variation in it. Of course, this is still a laboratory demo. It's a nice demo though, and it works pretty well if those numbers make sense to you. They don't make sense to me, but maybe someone of you has better insight. If you have a better insight, idea, suggestion, or second thought about this, let me know down below in the comments and we will discuss it. Maybe in next week's episode, maybe just in the comments. And yes, that's basically it what I have. I don't know what to think. It might be something great. It might be something that turns out to be bullshit, although it has been peer-reviewed because they received 25 April, the paper wasn't accepted until 15 June, and it was published online 27 of July. So yes, it's acknowledgements maybe or something. This paper is dedicated to the memory of American. No, nothing useful either regarding numbers and text. So yeah, it's I really hope for the scientists that worked on it that it's real and it starts to take off for them, because if it takes off, it can get the world so much closer to almost infinite source of clean water for everyone on the planet, and that's something we definitely need these days. Clean water is very important. No matter where you live, you need it. You can't live without it. And with that, I say thank you guys for watching. Subscribe if you didn't do that. Leave a like or a dislike, whatever you want. Read the article yourself at your own pace. Leave a comment down below if you did that, and let me know what you think. Hope to see you guys next time again. Thank you for watching.